All right, welcome back. Hopefully exercise 5A wasn't too difficult if you took a look at it, or if we're just going to go straight into the next video here. For the next part of sampling, I want to take a look at sampling techniques, and I want to talk about a word that has a whole different meaning today than, in popular culture than it really does when we're talking about probability and statistics. So this is sampling part 2 from 5.1. Let's look at some common sampling techniques. Some common sampling techniques. All right, so there's a few of these here, and we'll talk about them. So the first one is a simple random sample. A simple random sample. Now, the important thing in a simple random sample is that each member of the population is equally likely and unlikely to be selected. Each member of the target population, so whatever simple random sample we do, each member is equally likely and unlikely to be selected. Let's look at an example. Again, let's talk about our students. What would be a good simple random sample? Well, I could put the names of all the students on a slip of paper and put all the pieces of paper into a hat and then just randomly put my hand in and draw out a sample. Each name has equally likely and unlikely to be chosen. The next one is systematic sampling. Now, in a systematic sample, here what we're going to do is we're going to create a list of all of the members, all of the items in the population, and then we're going to select a sample according to some sort of random starting point and some sort of fixed interval. So we're going to select a random starting point and a fixed interval. All right, well, what does that mean? Let's go back to our students. So let's say we create a list of all the students in the school. And if I want a sample of about 200 students, then that's about 10% of our population. So I might start with a starting point. I start with the 37th student on that list. 37, just randomly pick a number, 37. And then I'm going to pick every 20th student after that. So I start with 37, plus 20, 57, plus 20, 77, and all of those students. Those are the ones that are in my sample. That's more of a systematic type of sampling. The next one is called stratified sampling. I-F-I-E-D, sampling. In a stratified sample, what we're going to do is we're going to take our population and divide them into non-overlapping groups. So we're going to divide the population into non-overlapping groups. And then we're going to take choose a random sample from each of those groups. The groups, by the way, are called the strata. The groups. And of course, I think in high school, we've got a very convenient strata we could divide all the high school students quickly and easily into 4 different groups: freshmen, sophomores, juniors, and seniors. The key is non-overlapping, so we would have to look at each person. Let's see, if we used the idea of how many credits you've got decides what you are, then even if somebody's been here for 4 years, they might think they're a senior, but if they don't have enough credits, they could be a junior or even a sophomore. So it's very important that these are non-overlapping groups, that any one particular member of the population could not be in more than one group at a time. The next one, I've run out of page. I'm going to go to the next page here. The next group is something called quota sampling. And the idea of a quota sample is it's kind of like stratified sampling, but it involves taking a sample size from each strata in proportion to the size of the population. So in quota, we have to have strata that are in proportion to the population. For example, what if we did that freshman, sophomore, junior, and senior? There's a lot more freshmen than there are seniors. Would it be fair? Would it be a true representation of our population if one of the strata had a lot more members in it than another one? We're going to look at an example of this coming up in a little bit. So, for example, if we knew that 30% of the students were freshmen, a quota sample would mean that we'd have to take 30% of our sample from the freshmen. It would have to be proportional to the population. The last one is the easiest, the most simple, very basic, and it's called a convenience sample. And just as it sounds, the convenience method is we just go up to whoever is easily available. So we're just going to select easily available members. Walk out there during lunch and say, hand out a questionnaire. Hey, how much homework do you have to do? That's a convenience sample. Just go around and just get the people that are close to you, nearby, quick and easy to get. A convenience sample. We've been using the word random and talking about the word random. I kind of want to spend a moment and talk about the word random. In today's society, the word random tend to be used to mean kind of haphazard or unpredicted or just kind of something that's happening randomly. But in statistics, it has a very different meaning. In statistics, it means that the probability of each of the members being selected is equal, random, truly random. Any part of the population is equally likely to be chosen or not chosen. Now, provided that the sample is truly random, then the mean of the sample is approximately equal to the mean of the population. Therefore, the sample mean, which can be found a lot quicker and easier than the whole population mean, can be used as an estimator for the population mean. You might have to watch the video and go back and listen to that message again, listen to that line again. A lot of important stuff in there. There's also a very interesting TOK tie-in right here. The idea of knowing something. And I don't know if you've had this in TOK yet, but the idea of what is the difference between information and data. Information versus data. Is there a difference between information and data? And that's a good TOK tie-in for that. All right, so let's look at an example now. Let's put some numbers here and look at an example and start talking about these things. So in this example, again, I'm going to think about my high school students, and I'm going to look at the class of high school students versus how many are in each class. So my class, I'm going to talk about my freshmen, and I'm going to call those the, if I have my freshmen, my sophomores, my juniors, and my seniors, and maybe I could break those up by ages. I'm going to call these my 18-year-olds, 17-year-olds, 16-year-olds, and 15-year-olds. And yeah, I know we've got some seniors that are 19 or 17 and freshmen that are 14, but let's just have this as a nice, convenient, easy number. And if I take a look at my entire population and I look at the frequency, and I'm going to say, well, what percent of the students at school are 15? What percent are 16? What percent are 17? What percent are 18? Now notice, all of these numbers should add up to 100%. Again, we're going to ignore any 14-year-olds or 19-year-olds. I'm going to try to make this a very, very simple. These numbers here are going to be very silly in a moment. They're not going to be true, but I'm trying to make the numbers nice and convenient. So let's say that in school we had a lot of 15-year-olds. Let's say we have 58% of our students are 15. Yeah, I know. Maybe 15% act like they're 15, but certainly it's a lot closer to 25% across here. 25% are 16. Only 12% are juniors. That would leave us, or 17-year-olds. That would leave us 5% that are 18. So I'm just trying to pick very nice, easy, convenient numbers here. So if I take a look at this and I want to find out information, and I'm going to do a sample here, I think pretty clearly that 58% of my sample should come from 15-year-olds, 25% should come from 16-year-olds, 12% of my sample, 17-year-olds, and 5% 18-year-olds. If I used equal amounts, if I did 25%, 25%, 25%, 25%, would that really be representative of the entire population? No. These guys here would have much bigger voice, and these people would not have as big a voice. So if my quota, if I set a quota of 200 people, Quota, 200 people. Then according to my frequencies here, I want to make sure that I've got the quota. If 200 people, then 58 times 2, I would have to have 116 15-year-olds, 50 16-year-olds, 24 17-year-olds, and 10 18-year-olds. Now you can see why I picked kind of nice, well-behaved numbers. So this would tell me how many students that I would have to have in order to have a representative subset, a representative population. Now the sampling process here is nice and quick, simple and convenient. But it might be difficult to find the appropriate amount of people. Asking and asking people ages might be a little bit sensitive too. We're going to talk about some of the pitfalls of questions and some of the things where this can kind of go horribly wrong here in the next lesson. But I just wanted to take a look at how we could break it out and make it nice and simple, and how the numbers could be nice. As we're choosing our sampling method, we're thinking a lot of times about what would be the easiest, what would be reasonable. But sometimes, like the convenience method, which is the quickest and easiest, is not the most reliable. We don't want to rely on that. We don't want to use that. And some of these other methods might require a lot of work and running around trying to find people and ask them. But if you want to have a valid sample, so that when you make conclusions about the sample, you can attribute those conclusions to the population, it has to be valid. It has to be a good, random, valid sample for your subset. All right, ladies and gentlemen, now we're done. Go ahead and work on exercise 5B. Good luck, and I will talk to you tomorrow. Oh, no, I won't. This is an AB class. I'll talk to you in a couple of days. Bye-bye.